Okay, we are starting out with section 1.1. This is in your assignment list. It's an objective. We will be doing objectives and assignments. We'll also be doing some worksheets and stuff. So, in our first chapter, we're going to start with circles. So, just remind me, that's a circle. What do I call that segment? Radius. Okay. What do I call that segment? Diameter. So any line from the center to the edge of a circle is called a radius, and all radii are the same length. Any segment that goes from one side of a circle to another and it passes through the center is called the diameter. And the diameter is exactly how big compared to the radius? The diameter is exactly double. Oh, yeah. So Money's saying, would this have the same length as the diameter? Yeah, it would. That doesn't have a name. But yes, you're right. Okay. What do we call the distance you would travel if you walked around the edge of the circle? Circumference. And what do we call this? The area. All of it. So we know that the diameter is equal to 2 times the radius. Okay. What about circumference? 2 times pi times r. Or you'll notice that d is 2 times r. So the circumference could also be listed as pi d. Right? Okay. What about the area of a circle? Area would be pi r squared. How do you remember the difference between these two formulas? Well, this is a distance. Distances are measured in inches or meters or feet or miles, right? This is an area. Area is measured in square feet or square inches or square miles. So which of the two formulas will square the distance? Only this one, right? So if the radius was, say, 5 inches, then the area would be pi times 5 inches squared. And that would give me 25 pi inches squared. So if you have trouble remembering which is which, just know that area has to be square units. And the only formula that squares the units is pi r squared. Okay? All right, so we're going to do, that's kind of review. Oh, wait. I'm going to keep those formulas up there. Okay, it's been a while. Got to remember how to do this. Okay, there we go. So, I'm a little bit rusty. Where's the mouse pointer? Oh, right there. It's been too long. This is not working. Okay, here's our first type of problem. 2 semicircles are placed in a rectangle. The width of the rectangle is 13 meters. So from here to here is 13 meters. Find the area of the shaded region, and instead of using pi, we're going to use 3.14. They only gave us one length. What would be 26? So you're right, something is 26, but what is 26? The diameter of the circle. So 13 is the width of the rectangle, which means that this is 13. And if that's 13, then this would be 26, and this would be also 26. Okay. And we want to know, what is this area? Well, in order to figure that out, what area do I need to compute?
Get 13 times 52, and then times that by 13. And then you would get the rectangle, and then you have to find the area of the circles, and then divide them in half, and then
So the rectangle itself, the rectangle is 52 times 13. So the area of the rectangle will be 13 times 52. So this area is 676. Okay, now what? I need the area of the two circle halves. Yeah, 2 half circles is actually equal to 1 full circle. So I can just find the area of the full circle using the formula pi r squared. What number will I plug into pi r squared? 13. So, and for pi, instead of using the pi button, I'm going to use 3.14 times 13 squared. So 3.14 times 13 squared. So the area of the circles is 530.66. Now what? Subtract the two. The area I want is the part of the rectangle that is not covered by the circle. So 767 or 676 minus the answer is 145.34. So I type in, oh, I don't have that keyboard anymore. 145.34. And then it's meters squared, or meters to the third? Meters squared. Okay. All right, so look at this one. How would we figure this out? Well, if this is 8, how big is that? It's also 8, because how do you know it's a square?
because it says that it's a square.
Good. It says that it's a square. If it didn't tell you, would we know it's a square?
We could guess.
Well, assuming that these are both radii, yeah. So the area of the square is going to be 8 times 8, which would be 64 meters squared. Okay? And what about the circle? How much of a circle do we actually have? All of it, and the radius is 4. So we would do 3.14 times 4 squared. And which one of those is going to be bigger? So this is the rectangle. This is all four pieces of the circle put together. And we would subtract them, and the difference is going to be that. Okay? All right. Okay. I want to know what is the difference between the areas of these two circles. So the big one is going to be 3.14 times 11 meters squared. And the small one is going to be 3.14 times 8 meters squared. What do I do once I find the big one and the small one? You subtract them. And the leftover will tell you the shaded area. Okay? Okay. How would you calculate that? It's a square. Good. We need to know that. How do you find the area of the square? 8 times 8, 64. And then the area of the circle? 3.14 times the radius, which in this case is 4, squared. And actually, this is exactly the same as the one we just did. And the funny thing is, if you took this piece and moved it, if I moved it to, come on, I'm trying to move it, but I'm not succeeding. Well, apparently I can't. Okay, there we go. So if I put this piece here and then that piece there, I would end up with something that looked like this, right? It's the exact same one that we just did, just in a different format. All right. Okay. If the circumference of a circle is 213.52, that would be the distance all the way around the circle, is 213.52. What is the diameter? So we have two circumference formulas. What are they? Circumference is equal to 2 pi r or pi d. So which formula do I want to use? The pi d. So if circumference is equal to pi d, what is d equal to? Not times. How do I separate multiplication algebraically? Divide by pi. And what happens to pi divided by pi? Cancels. So apparently, c over pi is d. So I just take 213.52 divided by 3.14, and I'm done. Is my answer going to be in yards or square yards? Yards. The answer I want is a distance. So my answer has to be in the form of a distance. Okay. All right, this one's a little bit harder. Gardner wants to put a fence around a rectangle with a semicircle on one side. So, good. The diameter of the semicircle is 25. How does that help us? C is pi d. So C is equal to 3.14 times 25. But this number is, well, it's wrong. Why? This right here is the circumference, which is the entire distance traveled around the edge of a circle. Is the fence going to contain an entire circle? No. So what do we need to do to this number? Divide it in half, and that goes here. I add up the other side. So I do 25 plus 31 plus another 31 up here plus whatever I get right there. Easy enough? Okay. Okay. So sometimes mathematically it doesn't make sense to do the decimals, which is a little confusing to you guys. But whenever you see exact terms, just don't plug in 3.14. Leave the pi symbol. So if this is my D, what would the circumference of this circle be? It's going to be pi D, which is pi times 10. So we're just going to write it as 10 pi. And that is called the exact value. It doesn't have the messy, irrational decimals attached to it. And in upper level mathematics, we often leave pi like that without transferring it into a decimal. Okay? If we did the same thing with area, it would be pi r squared. What is r in this case? 5 meters. So pi times 5 meters squared. So it's going to be 25 pi meters squared. That would be the area. And if I told you my yard has an area of 25 pi meters squared, you'd laugh at me because it doesn't mean anything, right? But, so if you're doing actual measurements, you always want to multiply it out and get the decimal. But when you're doing theoretical mathematics, it often makes more sense to leave it in pi form. Okay, next up. If I know, wait, this is the same basic problem, right? Oh, we're going to use 3.14. All right. So in this case, circumference is going to be 3.14 times 3 centimeters. And the area is going to be 3.14 times what? How would you find area? 1.5. So 1.5 centimeters squared. Okay. This is the same type of problem. And same type of problem. I just am interested, if I had a circle and I told you that the area was 50 inches squared, could you tell me what the radius was? So area equals pi r squared. So if I said 50 is equal to 3.14 times r squared, how would I get r by itself? Divide by 3.14, which I can do. So 50 divided by 3.14. And I now have 15.9 is equal to r squared. How would you solve that? How do you undo a second power? Take the square root. You would take the square root of 15.9, and my original problem was in inches squared, but my answer will be in inches. Because when we square root the 15.9, we also square root the inches, which makes sense because the radius is a distance, so it would have to be in inches. All right, get working on 1.1. Good luck.